Hey there, reality checkers. Imagine this. You're sipping your morning coffee, scrolling through your feed, and bam! You stumble upon a video that makes you question the very fabric of existence. What if I told you that everything you see, touch, and binge watch might be nothing more than an elaborate illusion? Yep, thanks to some brainy physicists, we're diving into a world where particles play long-distance relationships. The universe could be a sophisticated hologram, and your nosy neighbor might be influencing the cosmos just by peeking over the fence. Join us as we embark on this journey, questioning the nature of existence and the reality of our universe. In 2022, the Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger for their groundbreaking research that shattered our understanding of the universe. Their work centered around quantum entanglement, a phenomenon where particles become interconnected in such a way that the state of one instantly influences the state of another, regardless of the distance between them. John Clauser's initial experiments in the 1970s were pivotal in testing Bell's inequality, a theoretical limit on the correlations that can be observed in classical systems. Using polarized photons, Clauser's findings hinted at violations of this inequality, suggesting that particles were behaving in ways that defied classical explanations. These early experiments laid the groundwork for future research by highlighting the non-classical nature of quantum systems. In the 1980s, Alain Aspect improved upon Clauser's experiments by introducing a two-channel detection scheme and varying the orientations of the polarizing filters during the measurements. This refinement provided even stronger evidence of non-locality, the concept that particles could affect each other instantaneously across vast distances. Aspect's work demonstrated that the quantum world operates on principles that defy classical physics, reinforcing the idea that our understanding of reality needed a significant revision. Anton Zeilinger's experiments in the early 2000s took these findings even further. By conducting more sophisticated tests, Zeilinger conclusively demonstrated that the universe is not locally real. Local realism posits that objects have definite properties and states that are independent of observation and measurement. However, quantum entanglement defies this principle, indicating that our perceived reality might be a sophisticated illusion constructed by deeper underlying mechanisms. These experiments collectively challenge the classical view of a deterministic universe, suggesting instead that the universe operates on probabilistic principles. The implications of these findings are profound, raising questions about the true nature of reality and our place within it. Zeilinger's experiments also implied that the space-time matrix we navigate daily is not the ultimate reality. The laws of physics as we understand them are mere approximations, surface-level manifestations of a more profound and intricate quantum reality. When particles exhibit non-local behavior, they suggest that space and time are not fundamental constructs but emergent properties of a deeper, non-local reality. This revolutionary idea challenges the very foundation of our understanding of the universe. Space and time, which seem so concrete and absolute in our everyday experiences, may be nothing more than convenient constructs that arise from a more complex underlying reality. This deeper reality operates on principles that are fundamentally different from those of classical physics, leading to phenomena that are both mysterious and counterintuitive. The notion that space-time is an emergent property, rather than a fundamental aspect of reality, has far-reaching implications. It suggests that our universe is akin to a hologram, where the true nature of reality is encoded in a lower dimensional framework. This concept, known as the holographic principle, posits that all the information contained within a volume of space can be represented as encoded data on the boundary of that space. In this view, our three-dimensional universe is a projection of a more fundamental, two-dimensional reality. These ideas challenge our perception of reality, suggesting that the world we experience is a shadow of a deeper, more intricate reality. As we delve further into the mysteries of quantum mechanics, we may uncover even more surprising and unsettling truths about the nature of our universe. Another disturbing implication of these findings is the simulation hypothesis, which posits that our universe might be an artificial simulation created by an advanced civilization. This idea gained traction through the work of philosophers and scientists alike, including Nick Bostrom and Elon Musk. The anomalies observed in quantum experiments, such as the behavior of entangled particles, can be interpreted as glitches or artifacts of a simulated environment. The simulation hypothesis suggests that our reality, with all its complexities and intricacies, could be nothing more than a sophisticated digital construct designed to simulate physical laws and conscious experience. This notion is both fascinating and terrifying, as it implies that our lives, thoughts, and experiences are artificial creations within a vast and intricate computational system. Philosopher Nick Bostrom articulated the simulation argument in a 2003 paper, proposing that at least one of the following statements must be true. 1. Human civilization is unlikely to reach a stage of technological maturity capable of creating simulations of reality. 2. Advanced civilizations are not interested in creating such simulations. Or 3. We are almost certainly living in a computer simulation. This argument is based on the assumption that if it is possible to create simulations indistinguishable from reality, and if advanced civilizations have the capability and interest to do so, then it is statistically likely that we are living in one of many such simulations. Elon Musk has also expressed support for the simulation hypothesis, suggesting that the rapid advancement of technology, particularly in the field of artificial intelligence and virtual reality, makes it increasingly plausible that we are living in a simulated reality. As our own technology progresses, the line between reality and simulation becomes increasingly blurred, raising profound questions about the nature of existence and the intentions of our hypothetical creators. Adding another layer of mystery is the role of consciousness in shaping reality. Quantum mechanics has long suggested that the observer plays a crucial role in determining the state of quantum systems. The famous double-slit experiment, for example, reveals that particles behave differently when observed, collapsing from a wave-like state into a definite position. This observer effect implies that consciousness and reality are intertwined in ways that defy classical explanation. If the act of observation can influence the state of particles, then our perceptions might be actively shaping the universe around us. This blurs the line between objective reality and subjective experience, suggesting that our minds are not just passive recipients of information, but active participants in the creation of reality. The double-slit experiment demonstrates that when particles, such as electrons, are not observed, they exhibit wave-like behavior, creating an interference pattern on a detection screen. However, when these particles are observed, they behave like particles, creating distinct impacts on the screen. This suggests that the very act of observation collapses the wave function, determining the particle's position. The implications of this are profound. If consciousness plays a fundamental role in shaping reality, then our understanding of the universe must account for the interplay between the observer and the observed. This challenges the classical notion of an objective, observer-independent reality, and suggests that our minds may be more deeply connected to the fabric of the universe than previously thought. The concept of non-locality has far-reaching implications for our understanding of the universe. If particles can influence each other instantaneously across vast distances, then the idea of separateness is an illusion. Everything in the universe is interconnected in a web of quantum entanglement, transcending the limitations of space and time. This interconnectedness challenges the classical view of the universe as a collection of isolated, independent objects. Instead, it paints a picture of a holistic, interdependent reality where everything is fundamentally linked. This has profound implications for fields ranging from physics to philosophy, suggesting that our quest for knowledge must account for the deep interconnections that define our existence. The idea of non-locality is exemplified by the concept of quantum entanglement. When two particles become entangled, their properties become correlated in such a way that the state of one particle is instantly determined by the state of the other, regardless of the distance separating them. This phenomenon defies classical explanations, as it suggests that information can be transmitted instantaneously, faster than the speed of light. The implications of non-locality extend beyond the realm of physics, influencing our understanding of consciousness, information theory, and the nature of reality itself. It suggests that the universe is not a collection of separate, independent entities, but a unified whole, where everything is interconnected in a vast, intricate web of relationships. Expanded Chapter 6: The Frightening Reality of Quantum Mechanics. The more we delve into the quantum realm, the more unsettling the discoveries become. Quantum mechanics defies our intuitive understanding of reality, presenting a world that is fundamentally unpredictable and governed by probabilities rather than certainties. The Heisenberg Uncertainty Principle, for instance, states that we cannot simultaneously know a particle's exact position and momentum. This inherent uncertainty suggests that the universe operates on principles that are fundamentally different from our macroscopic experiences. The Heisenberg Uncertainty Principle is a cornerstone of quantum mechanics, highlighting the limitations of our ability to measure and predict the behavior of quantum systems. It implies that the more precisely we know one property of a particle, such as its position, the less precisely we can know another property, such as its momentum. This inherent uncertainty is not due to experimental limitations, but is a fundamental aspect of the quantum world. The concept of superposition further complicates our understanding, as particles can exist in multiple states simultaneously until observed. This phenomenon challenges the classical notion of a singular objective reality, suggesting that multiple potential realities coexist until a measurement collapses them into one observed outcome. In the famous Schrödinger's cat thought experiment, a cat is placed in a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the Geiger counter detects radiation, the vial is broken and the cat is killed. If no radiation is detected, the cat remains alive. Until the box is opened and observed, the cat is considered to be in a superposition of both alive and dead states. This paradox illustrates the counterintuitive nature of quantum mechanics and the role of the observer in determining reality. These unsettling concepts force us to reconsider the deterministic view of the universe held by classical physics. In the quantum realm, certainty is replaced by probability, and reality becomes a fluid and dynamic tapestry woven by the interplay of observation and measurement. As we continue to probe the depths of quantum mechanics, we may uncover even more disconcerting truths about the nature of our existence. The philosophical dilemmas. These scientific revelations pose profound philosophical questions about the nature of existence. If the universe is not real in the way we perceive it, what does this mean for our understanding of reality? Are we mere figments of a cosmic imagination, illusions within a greater incomprehensible framework? The philosophical implications are staggering. The idea that reality is an illusion challenges the very foundation of our knowledge and beliefs. It forces us to reconsider the nature of truth, the reliability of our senses, and the essence of our being. If nothing truly exists as we perceive it, then what is the true nature of existence? Philosophers have long debated the nature of reality and our ability to perceive it accurately. Descartes' famous dictum, cogito, ergo sum, I think therefore I am, posits that the only certainty is the existence of the thinking self. However, the findings of quantum mechanics challenge even this foundational assertion, suggesting that our perceptions and experiences may be mere constructs within a deeper, more complex reality. The simulation hypothesis adds another layer of philosophical complexity, raising questions about the nature of consciousness, free will, and the purpose of our existence. If we are living in a simulated reality, what does this mean for our understanding of morality, ethics, and the pursuit of knowledge? Are our experiences and actions meaningful, or are they predetermined by the parameters of the simulation? These questions have no easy answers, but they compel us to explore the boundaries of our understanding and to seek deeper insights into the nature of reality. As we grapple with these philosophical dilemmas, we may find that the quest for knowledge is as much about understanding ourselves as it is about understanding the universe. The future of quantum exploration. As scientists continue to explore the depths of quantum mechanics, we can expect more unsettling discoveries that challenge our understanding of reality. The quest to uncover the true nature of the universe is far from over, and each breakthrough brings us closer to a fundamental understanding of existence. Future experiments will likely delve deeper into the mysteries of quantum entanglement, non-locality, and the role of consciousness in shaping reality. As we push the boundaries of technology and explore the frontiers of science, we may one day be able to answer the question definitively. Is the universe real, or is it an elaborate illusion crafted by deeper underlying principles? Advancements in quantum computing, for example, hold the promise of unlocking new levels of understanding in quantum mechanics. Quantum computers, which leverage the principles of superposition and entanglement, have the potential to solve complex problems that are currently beyond the reach of classical computers. These advancements could provide new insights into the nature of reality, allowing us to simulate and study quantum systems with unprecedented precision. Additionally, collaborations between physicists, philosophers, and computer scientists may yield new theoretical frameworks that integrate the findings of quantum mechanics with broader philosophical questions about existence and reality. These interdisciplinary efforts could pave the way for a more holistic understanding of the universe, bridging the gap between empirical science and existential inquiry. As we continue to explore the quantum realm, we may also uncover practical applications that revolutionize technology, medicine, and communication. Quantum encryption, for instance, promises to provide unbreakable security for digital communications, while quantum sensors could enable unprecedented levels of precision in measurements and imaging. The future of quantum exploration is full of promise and uncertainty. As we journey further into the unknown, we may find that the answers to our deepest questions about reality are more complex and profound than we ever imagined. Each new discovery brings us closer to understanding the true nature of the universe and our place within it, challenging us to rethink our perceptions and embrace the mysteries of existence. So tell me, what do you think? I guess this is just another file opened beyond our imagination. So next time you stub your toe or lose your keys, just smile and think. Maybe it's just a glitch in the matrix. Thanks for joining us on this cosmic adventure. Don't forget to please like this video to push it to all the science nerds out there. Subscribe, hit that notification bell for more mind-blowing videos with us, and also comment topics you want us to talk about here on the channel. Stay curious, stay skeptical, and as always, keep questioning the reality around you. See you in the next video.